Again, looking at the homework, this is the constant rate of change homework. I wanted to look at number 11. I felt like that was probably the most difficult of all of them. It says Jazz was 43 inches tall. 18 months later, okay, 18 months later, she was 52 inches tall, so that's important. Determine the constant rate of change for Jazz's height. So I'm going to go ahead and make a table of x and y values. And if I put 43 inches here, 18 months later she was 52 inches tall. So whatever this number is going to be plus 18. And I'm just going to put a 0 as my placeholder there because it says 18 months later. So however old this person started 18 months before, we just don't really know what it is, so we're just going to substitute that 0 in. The 18 later just means that this is a plus 18, and Jazz was 52 inches for that. Now, if I'm doing change in y over change in x, I already have my plus 18 here, and over here it's plus 9. Delta y over delta x. Delta y would be 18, and delta x would be 9. If I simplify that, that's an answer of 2. But let's look at the question. It says she's 43 inches tall, then she's now 52 inches tall. The constant rate of change. Does 2 inches make sense to change every month? If that were true, then 18 months later, we would be multiplying that by 2. That would be much too much to go from 43 to 52. So this is why I set it up this way, because I want to make a point. My x and y are flip-flopped. I need to make sure that my y value is not the age, that it's actually the height. So y needs to be the height. And what that does is it just changes how I set up my delta y and my delta x. So this is plus 9, 43 inches, plus my 18. So now my delta y is 9, my delta x is 18. If I simplify that, that's a half. So then does it make more sense that this person gains a ½ inch every month? Yes.